Hey guys, what we're gonna do in this one is see how to convert. No, we're not gonna convert anything. We'll learn how to find out the intervals when we get a positive or a negative answer for a polynomial. And without wasting any time, let's get on to the sums. Here we have x squared minus 7x plus 10 over x squared minus 9, which is equal to x minus 5 into x minus 2 whole taken over x plus 3 into x minus 3, sorry. Now if you're wondering how I got this, then you can just go back to the videos of factorization and you'll see. And now this one term gives us a 0, which is 5. This term gives us a 0, which is a 2. This term gives us a minus 3, and this one gives us a 3. I'll consider this whole thing as a k because I don't want to repeat the whole term again and again during the sum because I'm extra lazy in that. And here we have a number line. To solve it further, we'll draw a number line and plot all these zeros, keeping in mind that the zeros on the denominators come as hollow circles and the zeros in the numerator come as darkened circles. So here we have minus 3, we have a 2, we have another 3. Oops, that was a denominator, so we'll just color it back black. Okay, so we have a 3, and then again we have a 5 from the numerator. Oh, that's 3. So now what we're gonna do is take this interval as positive always. This is positive. This part here will be negative because the term that gave us the 0, 5 has a power 1, and 1 is an odd number. If we had an even number here, an even number, we would not change the sign and continue with the positive 1, but because we have an odd power here, we'll make this negative. And now the 0 is 3, that's come from this, and this again has a power of 1, so we'll again change it positive. This one again has a power of 1, so we'll change it to negative. This one again has a power of 1, which is tiny little 1, you can see or not, I don't know, and this one's positive. So the outcome of this whole mess is that k will be greater than 0 whenever x belongs to minus infinity to minus 3 union 2 to 3 union 5 to infinity. These are all the intervals when we had a positive sign here, and all that positive sign means is that your answer will be positive when you use these terms as an x. So yeah, now if this k here had an equal to sign along with this, if it was greater than or equal to, all the change that would have been here is that these terms which have a darkened circle would be included in our interval. So this 2 right over here, this would become included, and this 5 right over here would become included. And you know from your past experiences at Khan Academy that your terms which are included are supposed to be given in square brackets. So you have a square bracket right there and one more square bracket right here. Now we can do the same for whenever k is less than or equal to 0, and you might be knowing it by now that it's so whenever x belongs to minus 3 to 2, That one there is a parenthesis, that's not a square big bracket, don't misunderstand that to be that. What's that to be that? Okay, the next interval is 3 to 5. Okay, now we'll go on to another sum. And there we have it. So, the sum is x cubed plus 12x squared plus 45x plus 50 whole over x plus 5. Now that's a huge term. You might think there's some difficult things going on here for factorization, but that I'm not gonna mention in the video, and I'm sorry for that. This whole term I'll again, due to laziness, take as k, and here we have our factorized term, which I have already factorized and known that it's x plus 5 squared into x plus 2 whole over x plus 5. Now, you have the same term in the denominator as well as in the numerator, so you can cancel it. The square will cancel x plus 5, and what's left is x plus 5 into x plus 2. But remember that this is now an odd power because it's been cancelled. It's power 1, and even this is power 1. And the one mistake which people generally make is forget that this is an open 0. You have cancelled it out, but even now if you take minus 5 as x, you're gonna have the answer as infinity. So avoid making this mistake and put a gentle hollow circle for minus 5 and a colored one, fancy little 2, or maybe minus 2, yeah, minus 2, and then mark your terms positive and negative. You have a plus here, and because 2 is from an odd power, you have a minus again, and because this is from an odd power, you have a plus again. If it would have been 2, if there had been no x plus 5 here, it would have been 2, and this term here would not have been a plus but a minus. This plus is missing the top. It would have been a minus, and this hollow circle would have been a dark circle. And if this whole term had started with a negative sign here, you would not be able to apply this thing as it is. You would have to go with a minus sign in the starting, and then a positive, and then a negative. Okay? And one more thing I want to tell you, because I don't have a sum of that kind and I don't have the brains to make that, I'm gonna use one, but I'm gonna tell you, never ever multiply this denominator to this side, because even in this one, if you multiply this x plus 5 over here, you'll have one more x plus 5 over here. But what you don't know is whether the x is positive or negative. This whole term multiplied into this 0 would give you a 0, but this term, if it's positive, will keep it as it is, and if this term is a negative, this sign over here would change to less than or equal to, and this thing over here would become a positive. This would become a positive. So just keep that in mind. That's not something that generally happens, but if in case that you encounter something like that, you should keep that in mind. And with my favorite color, I'm going to mark the answer. Okay, this might not suit, my color sense is not good as Khan, but yeah, I love this color. So k will be greater than or equal to 0 whenever x belongs to minus infinity to minus 5 union minus 2 to infinity. And we're done.